Okay, can we start now?
Yes, I think we can start now.
Okay, thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon,
Waalaikumsalam.
good afternoon, everybody. Thank you very much for your joining for joining the Zoom meeting or webinar meeting today. So I will introduce myself. My name is Haznan Abimanyu. I am rolling as a moderator this afternoon for the tentative for the JAAI lecture today. So I am the vice chairman for the JAAI in Indonesia. So I am also the head of a research center for electric power and mechatronics LIPI. So I will read for you the tentative agenda for today meetings. So that's all was the brief introduction from me as a host or moderator. So after this, Professor Wahyu Dwianto, as the chairman of JAI, will deliver the opening speech for this webinar. And after that, the presentation by Professor Manabu Ihara, and then from Professor Dwi Susilaningsih, and then the last presentation by Associate Professor Suntoyo. And after that, after the presentation, we will have the general discussions, so questions and answer. So for the attendees in the Zoom meeting, can write the question in the chat room in Zoom meeting with the format name of the attendee and to whom the question will be addressed. And after the general discussion, we will conclude this today webinar. And finally, closing remark by Professor Yosho Otani, Director of JSPS Bangkok office and photo session. So let's start. Sorry. Let's start for the opening speech by Professor Wahyu Dwianto, Chairman of JAI. Professor Wahyu, time is yours.
Thank you very much, Dr. Haznan Abimanyu. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Good afternoon, everyone. Konnichiwa and selamat siang. First of all, let us thank Almighty God for blessing that we can get together today in this event. On behalf of JSPS Alumni Association of Indonesia, or JAI, I would like to extend the warmest welcome to all participants. Mr. Tsutomu Ikeda, Deputy Director of JSPS Bangkok Office, Professor Yoshio Otani, Director of JSPS Bangkok Office, and the lecturers who have been willing to attend this event. I saw in the list of participants that Ms. Sachiko Hoshimoto from JSPS International Policy Planning Division, Headquarters for International Affairs, is also attending on this event. Thank you very much for your coming. JAI was established in the Declaration and Congress of JAI on November 17, 2016 in Cibinong, Bogor, and it formally inaugurated on March 9, 2017 by ceremony of inauguration in Jakarta. JAI is the 7th association among 20 alumni associations in the world. Now JAI grew to having 147 members, making it one of the largest alumni associations in the Southeast Asia. In this occasion, I would like to invite all of you to be a member of JAI. The objective of JAI are to organize symposium and to promote scientific exchange, research and culture collaboration, and to give scientific recommendation on science and technology to Indonesian government. JAI focuses on food and health, new and renewable energy, Environment and Related Sciences, and Human and Social Sciences. Among other activities, such as selection of candidates for JSPS Bridge Fellowship Program, holding focus group discussion, and annual symposium. Today, JAI conducts the second lecture with the topic of alternative and prospective of new and renewable energies. The first JAI lecture was successfully held on July 24, 2020, with the topic of managing COVID-19 pandemic, experience from Japan and lesson learned for Indonesia. Besides two other Indonesian lecturers, Professor Dwi Susilaningsih from Research Center for Biotechnology, Indonesian Institute of Science or LIPI, Bogor, and Associate Professor Suntoyo from Sepuluh November Institute of Technology, Surabaya. We invite Professor Manabu Ihara from Tokyo Institute of Technology, Japan as well. Last but not least, I would like to thank Dr. Haznan Abimanyu, Head of Research Center for Electronical Power and Mechatronics LIPI, as a host and moderator of this event. He is a Vice Chairman of JAI on New and Renewable Energy Sciences. Thank you also I would like to convey to Dr. Iman Hidayat, Head of Research Center for Biomaterials LIPI, and Mr. Agus MP as organizing committee in collaboration with JAI that make this event available. Finally, I wish all participants to enjoy this JAI lecture. Thank you very much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Wahyu Duyanto, for the opening speech. Maybe you officially open this webinar, please.
Okay, I now officially open this second JAI lecture. Thank you very much.
Thank you. Thank you, Professor Wahyu as Duyanto for the opening of this seminar. So let's start with the presentation, first presentation delivered by Professor Manabu Ihara. So before I want to read briefly the biography of Professor Ihara. So Professor Ihara is graduated from Department of Chemical Engineering, the University of Tokyo in 1994 for his Ph.D. And then he got the assistant professor in the University of Tokyo from 1994 until 1997. And then assistant professor in Tohoku University until 2004. Then from that, he moved to Tokyo Institute of Technology in the Department of Chemistry, Research Center for Carbon Recycling and Energy from 2004 until 2015. So from 2015, he is the professor still until now in the Department of Chemical Science and Engineering, Department of Chemical Engineering in Tokyo Institute of Technology. And he is also as the Vice Director of Interdepartmental Organization for Environment and Energy in TIT. And also he is also the advisor to the President in Tokyo Institute of Technology. Tokyo Institute of Technology until 2018. So his current research topics is solid oxide fuel cells with various fuels, hydrogen energy storage using solid oxide, electrolysis cells, monocrystalline SE thin film solar cells with low cost, perovskite solar cells, nanostructured silica solar cells, and plasmonic solar cells, and the energy system analysis and development of smart energy system. So, Professor Ihara, time is yours.
Okay, thank you very much for a great introduction. And also thank you very much for every coordination, every person to organize this symposium. I'm very, very happy to have the presentation and introduce especially for the energy system, applying and carrying out in the Tokyo Tech now. So can I share my slide by myself?
Yes, of course.
Okay. Yeah, that one.
Yes,
Yes,
we
first
see.
of all,
Yeah, we already, yeah.
Okay, first of all, this is a photo. It's in my building now. I am in around here in my office. Okay, so this building is covered with the solar panel, and this is is located at the Okami campus in the Tokyo Institute of Technologies. Beside my building is Tokyo Line that's passing through now. Okay. And today's my topics, especially for the smart energy system, is the smart energy system is operating at this core research center of energy research center is here. And so toward the future, we would like to make development or distribute the smart energy system with hydrogen energy. So at also same time, I would like to introduce our Tokyo Tech energy strategy, collaborate with the industry, and also I would like to introduce the educational program for the PhD student. So I hope that every student, every person, and interested in the educational program also. Okay, I'm the the professor in the Department of Chemical Science and Engineering, and also the head of Tokyo Tech Energy Research and Educational Consortium relating with energy research and education. Okay, first of all, and I would like to speak the recent impact to the energy sectors. As the first impact is very, very well known, is the Paris Agreement in 2015. In the Paris Agreement, there's a COP21. And every people in the Earth have to approaches that keeps the global average temperature below the 2 degrees above pre-industrial level. Just 2 degrees, but this target is very, very challenging now. And after agreement, COP21, in Japan also in the world, the investment is very influenced by the disagreement. ESG investment is very, very well known, the investment way. Environmental social governance investment way is one of the main method, main target to the investors. The second impact in the energy sector is the drastically dropping down the energy cost from renewable energy. For example, this is the solar cell systems, the price in Japan and USA and Germany. You can see that from 2007 and 2016, you can see that especially for after 2013, recent 5 years, almost 5 price of the solar cell installation cost. And especially for 2016, it's very, very surprising news. Is in Abu Dhabi. Of course, in Abu Dhabi has a longer radiation time of the sunlight, but in the US 2.40 cents per kilowatt hour. It's very, very cheap cost was achieved in a contract. So in the toward future, so today is a topic also the renewable energy, variable renewable energy. We call it the VRE parcels will be increased in the future. Next impact is in the energy sector is the keeping the voltage in the grid. This is Japanese data in Chugok Electric Company's area and the Kyushu Electric Company area. So it showed the one day in 2017 and one day in 2018 in the summertime. And in Chugok Electric Company, this area, this is red one and the summer power. This is a Kyushu red power, summer power. It was increasing solar panel in around 8 to the 12 near the noon, and increase of the amount of the generating power from solar cell is increased to keep the voltage in the grid. Of course, in supplying the electricity from power source have to exactly same as the consuming electricity to keep the stability, to keep the voltage in a commercial electricity grid. So, and each electric company manage according to the increase of the solar cell, and in a Chugok Electric Company, an increase of the pump up and a kind of the storage of the electricity. In 2017, in a Kyushu area, also the same, and just reducing the power from the summer power and also pumping up as an absorber of electricity. But 2018, as Chugok Electric Company, also the total amount of electricity from solar power has increased. But at the Kyushu Electric, it's okay. This company can be managed correctly. In the Kyushu Electric Company, 2018, so after the earthquake, the Japan's nuclear power plant was damaged by the tsunami attack. So recently, 2018, new nuclear power plant that's starting up. So the increase of the solar cell, the Kyushu Electric Company have to suppress the electric power from solar cell. So that I can say that it's recently in Japan, in Europe, or also every country, we have to think about the adjustment power to stabilize the electric grid. So next question about power, the future energy system. Concentrated electric energy system, or distributed one. And this is I would like to introduce the activity of the International Council of Academy of the Engineering and Technological Science. In that meeting, the topic is transitioning to the low carbon economy. This report was completed little before 2015. And the participating countries, Australia, Canada, China, and Germany, India, and Japan, and Korea, and South Africa, and Switzerland, and the UK, and the US. I was the representative of the Japanese Academy of the Engineering. I participated in this report. And this is one of the things. This is a conclusion. So the question is that toward the future is a concentrated electricity grid remain, or the changing to the distributed power grid will also connecting to the large scale of the electricity grid. The answer in this academy. This is the small size of the microgrid, called as a microgrid. Small distributed energy systems has to be connected to the concentrated one. Reason why it is because for the distributed system, small size system has an advantage of that improvement. We can improve the heat usage at the power generation, because we can transport the electricity easy using the grid. But heat is due to the low energy density. We cannot easily transport from the heat energy to far away from the city. And also, if we are focused on the stability of the electricity grid, there's various methods. There's a small size of the battery or some controls the demand. There's various methods to keep the stability of the grid. So that in the future, in a toward future, low carbon and with sustainable economic growth, the toward future, we have to make the nice energy system, concentrated energy system with various kind of size of the small size of the distributed energy system connecting to each other. That is the future image of the energy system. We have to change in the future. So in this moment, in this point, the technical issue is an important system design and control. One example is this is a Toyota company, the Prius, the hybrid car. Energy conversion efficiency of the car with popular gasoline engine is normally energy conversion efficiency about 16%. But the hybrid car in a website and Toyota companies and is released at about 37%. And also fuel consumption is higher, is in the data in 40 kilometers per liter. So reason why? The hybrid car has the gasoline engine and the motor. And power source has two power sources it has. And so how can you control this car? And the gasoline combined with the gasoline engine and the motor. So combined, so it means the system design. And also how can we control the power source for each? So the importance by the nice system design and control, the total energy conversion efficiency improved from 60% to the 37%. So one of the case for that. The next case is our cases. I designed the energy system in this building. We have 4,500 solar panel surrounding the surrounding the building. And Tokyo Tech was designed as new research building. This research building should act as a core research center in the Tokyo Tech of the energy research. And also it's designed as the low carbon dioxide emission. The target is 60% reduction. And also so we try to find the energy system to self-sufficient electrical power. Today, I don't have enough time to explain the detailed energy system, but the one example about the setting way for the solar cell, I would like to introduce for that. And this building's construction was completed at about 6 years ago. At the moment in the solar panel, I said in the beginning, this is solar cost of the installation of the solar cells system is drastically dropping down within the recent 5 years. Before the 5 years, the solar cell price is almost double. It's not so cheap compared with the present price. So at the moment, we expected to discuss with the many professors regarding to the energy sectors. And so this setting way is usually a cost of performance of solar cell is highest priority matter for the design. But we're changing mind toward the future. We would like to maximize the generated electricity from the solar cell per year. Of course, the sunlight is the angle, irradiated angle to the building. It's changing in a day and in a season. So totally in a year, we have to find the best design to set for the setting way of solar panel. So one solution is for that. So this shape is quite strange. Some people say that like a cake. Some people say like the battleship. But this shape itself is coming from the design to maximize the solar panel, solar cells generation electricity. And we have the experimental floor and desk floor, and for the desk floor, we don't need the direct irradiation of the sunlight. So the flat panel setting way was applied. In contrast, for the desk room, we need the Duba type and the reflected light on the surface of solar panel introduced into the space. One of the advantage for the Duba type of the setting way. In a desk room, the people would like to see that the direct irradiation of the sunlight, especially for the winter season. So for example, and also at Toward the Future, we think about the special angle. So I will show that. In the winter and at 10 o'clock in the morning, this direction, it's south, okay? So sunlight irradiated from the right side, and about noon, and the whole solar panel receives mainly the sunlight and generating electricity. And in the afternoon, now is about around 3:30, and left side of the solar panel receives the sunlight. And finally, before the sunset, the west side wall of the solar panel receives the mainly of solar. So main solar wall for power generation was shifted depending on time and the season. So in the variable parcels, the important point is a leveling of the power generation. So in that data, this is only the roof. This is a typical setting way in solar panel. In our building, the total amount of power of course in the summer is high, but higher than the summer season. Winter season is higher, and almost leveling. And combination of the different kind of the angle of the solar setting way is one of the method to leveling. And toward the future, and the storage is energy storage is very important role to keep the energy system. So in that way, also the storage battery, and like sometimes we would like to use the hydrogen energy storage, and but also that we have to adjust by using the setting way and the leveling of the power generation of the solar cell. That is one of the examples. And in a building, and solar cell is 650 kilowatt in a building, and also phosphoric acid fuel cell, whose capacity is 100 kilowatt. And using the exhaust heat from the waste heat from the fuel cell, we can play at the absorption refrigerator to make the cooling water in the summer season. Also, the Indonesia, also Japan, the Asian country have the high humidity, especially in the summer season. So to keep the comfortability in a room, we have to reduce the humidity. As one efficient way is a disk and air conditioning. So to operate the efficiently operate the disk and air conditioning, the waste heat is useful. And also otherwise geothermal heat pump and some efficient control and everything, and to reduce the carbon dioxide emission, the technology. So I would like to value the power source in the future. Of course, economic competitiveness, the low cost of power generation is necessary. And of course, we need the improved of the total efficiency. Also, due to the Paris Agreement, we have to go for the low carbon society and free carbon society. So carbon free is required as the future process. Also, to keep the voltage of the electricity grid, adjustment to the power in the grid is a necessary factor, necessary function for the power source. So that we have the various energy mixture, mainly from the renewable energy, and a combined system between the concentrated and distribution energy system, and also important technologies as elementary technologies, energy storage is required. Of course, battery is one of the key technologies it has, but long and large amount of energy storage, the hydrogen can be act as a energy storage, as a chemical energy storage. So we are in a group, a research group, we are summarize two kind of the option the hydrogen is. First one is the option for a global resource allocation of energy under restriction of greenhouse gas emission. We call that global hydrogen. It's hydrogen is not primary energy, so the thinking way with global hydrogen is, for example, for example, here is Australia and so that we can make the hydrogen using the solar power and wind power and brown coal with CCS and making the energy carrier. And the candidates are liquid hydrogen and ammonia and MCH and transport of the hydrogen and deliver it to the Japan or every country and the use of the hydrogen. This thinking way, and including the supply chain, this thinking way is global hydrogen usage. Second option is local hydrogen. Option for local energy storage at large amount of renewable energy installation under restriction of electric demand leveling. It's, of course, when using local hydrogen, cost of carbon dioxide emission for fabrication of energy carrier, dehydrogenation and transportation, and can be eliminated compared with the global hydrogen. But in contrast, electricity itself, compared the price of the electricity cost in Japan, and it's much expensive compared with the Abu Dhabi's, these countries. So advantage and disadvantage. So toward the future, as an energy storage, global hydrogen, local hydrogen has to be used in the future. This is one example in energy system. And in our Tokyo Tech Open campus, we have the data point 8,000 point per second per minute. We have big data, energy big data stored in the developing the smart energy system called as NSwallow, and coming from energy. Swallow is our Tokyo Tech simple market is Swallow. So NSwallow is the name of the smart energy system we developing now. Collaborating with the hydrogen, the company and the car company and collaborate with the supercomputer of the Tsubame 3.0. That is in 3 years ago and was the #1 at the Green 500 with performance supercomputer. So the collaborating to promote the collaborating with the industry. We organize the Tokyo Tech Info Synergy Consortium. And Info Synergy is a mixed word in informatics and synergy and energy. So our mission is using data science, and we are researching on the elemental technology of the material of the battery and material of the electrode, and also energy system technologies. And also important point is that we make the vision toward the future. So together with the educational program, our goal is to design a new sustainable energy society. So in the consortium, so we set the 9 important research topics: and system development, technology for renewable energy base load relating to the nuclear power plant, and solar energy conversion technologies, and the fuel cell electrolysis technologies, energy storage technologies like batteries, energy carrier and low carbon process by catalyst, and relating to chemistry. And hydrogen combustion, heat utilization, and future energy technologies. And so that's a vision. And also how can move toward the future. The scenario study is necessary. 9 research topics are set in this consortium. Totally 70 professor and associate professor are joined to this consortium. So, and the many companies, 26 company as a top company are participating in the collaboration, and also the in the world, and well, top university and EPFL in Switzerland, Georgia Tech, USA, and Imperial College London, UK, and KAIST, Korea, and MIT, USA, and Nanyang Technical University, and Singapore, and University of California, Santa Barbara, and Cambridge University, and University of New South Wales, and Hitotsubashi University in Japan, and inside here in France, Princeton University, USA, Aachen University in Germany, Sinful University, and University of Stuttgart. This university participating in the consortium toward the sustainable energy society. So we collaboratively research work and education. We would like to do that. So recently, the nice news for about educational program. The WISE program is the government support, yes, including JSPS. Thank you for JSPS. And recently this year, and our program, Tokyo Tech program, was adopted. And it's very competitive today, this year. 42 applications from 27 universities. Just 4 universities adopted. And our Tokyo Tech is one of the highest top university, and only 3, and Tokyo, the University of Tokyo, and Kyoto University, and Nagoya University. It is the very 3 and 4 program was adopted. This is a 7 years project, and only one project on energy in Japan. Only one about energy. And also we would like to construct and establish the Tokyo Tech Academy, new educational organization, Tokyo Tech, focusing on energy technology and informatics. And 4,200 million Japanese yen, and they are reducing in the future. This is a multi-scope and yes, energy science, and also big data subject we have, and also to make the social design scope. So multi-scope meaning that 3 kind of the scope. We'd like to produce this kind of human resources as a PhD student. Okay, no, not PhD, as the doctor, multi-scope energy wise professionalist. And for the student, yes, good financial support. And we recruit the PhD student from over the world, of course, in Japan and outside, also the Indonesia, from all over the world. We would like to recruit and screening, and the top PhD student will join to this academy of energy and informatics. And for the student, has a big advantage with good financial support to the student. As maximum 2.4 million Japanese yen per year during the PhD course. Okay, so we kind of the representative innovation. And one is the venture business person to establish a venture business. And a person through a doctor to driving a new business in a company. And also the professor, doctor as a professor and reading the government. So this is the final, my slide as a conclusion. As a Tokyo Tech energy strategies, and this is producing a multi-scope energy-wise professionalist. And from now, from next April, we'd like to recruit the student, excellent student. And also educational research. And the core is our Tokyo Tech innovation in building and developing new energy technologies using big data. So finally, we sorry, approaching okay, approaching the right. Okay, yes, ambient energy society. This is preventing the global warming and economic advantage and growth. We would like to drive innovation toward the sustainable energy society by producing both human resources and new technology. That is our Tokyo Tech energy strategy. Thank you very much for your attention.
Okay, thank you very much, Professor Ihara. Nice and interesting presentation from Professor Ihara. So I'm not going to deliver the conclusion or something like that. So we move to the next presenter, Professor Dwi Susilaningsih.
Okay.
Are you ready? So
yes.
Time is yours.
Yes, thank you, Haznan-san.
I'm sorry. I forget to read your biography. So
okay, go ahead.
Yeah, I'm going to read the biography of Professor Dwi Susilaningsih. So she was graduated from International Graduate School of Pharmaceutical Sciences, Osaka University, for Master and Ph.D. In 2003. She is a senior researcher on marine microbes that focus on utilization of the photosynthetic microbes, such as bacteria and microalgae, and its association for useful application in health, food, remediation, and energy fields. And she has more than 100 publications and at local and international publisher, holding the 7 patents on microalgae and energy, and also released the microalgae products such as a health supplement and contribute on LIPI hydrogen scooter assembly. So currently, she is a leader of the laboratory that developing the high rate production of biohydrogen from photosynthetic microbes, algae, and bacteria, collection and screening tropical microalgae for energy and natural pigment purposes, and bioremediation of soil and seashores. So she received several grants projects from Indonesian government and also from international funds like ITFS Japan, NITE NADO Japan, and Semeo Biotrop. And she is also actively organized and joins the Science and Environmental Foundation in Indonesia. So now time is yours, Professor Dwi.
Thank you, Pak Haznan. Okay, very good afternoon, ladies and gentlemen. Konnichiwa minasama. Selamat siang. Assalamualaikum warahmatullahi wabarakatuh. in this good opportunity, I would like to share our research experiences about the research development of tropical microalgae as source of fourth generation of biofuel. Maybe this is only a small part of Professor Ihara work. However, I still would like to introduce to everyone. And the presentation will including the microalgae diversity in Indonesia to the application of the microalgae for the energy for biodiesel and biohydrogen and also refinery. I will go to the introduction. What is the bioenergy? Prof. Ihara talking about the big picture about energy, new and renewable energy. One part of the new and renewable energy is the bioenergy. That energy comes from the biological sources. So maybe in the small, not so complex structure, also can be very complex structure like lignocellulosic feedstock. So anyway, we will use this kind of the sources to be bioenergy, such as maybe biogas, maybe pellet, or maybe also liquid bioenergy. Inside the bioenergy, we have the biofuel, that bioenergy using for the like transportation, electrical power, or also heating. So now like booming from the corn, from the sugarcane, so we can convert this kind of the biomass or the compound inside the biomass to be bioethanol, biodiesel, and also biogas. And from the technology part and also a development of the materials of the biofuel, there is they call the biofuel generation. There is like first, second, third, or fourth generation biofuel. They are characterized by their sources of biomass, their limitation as renewable source of energy, and their technological process. The main drawback of first generation biofuels is that they come from the biomass that also are food sources. Second generation biofuels come from the non-food biomass, but still compete with food production for land use. Finally, third generation biofuels present the best possibility for alternative fuel because they don't compete with food. However, there are still some challenges in making them economically feasible. Using the high technology effort, economic efficient by exploring microbe as sources will lead to fourth generation of biofuel. I would like to introduce the one of the sources of fourth generation of biofuel. There are microalgae. Microalgae are microscopic unicellular algae typically found in the freshwater, marine, existing in individually or in chain or groups. Microalgae are extremely diverse group of organisms which include both prokaryotes and eukaryotes and covers around 14 phyla with examples described from almost every possible habitat, and estimate around 200,000 to 800,000 species of microalgae is widely quoted, of which only about 35,000 are described. So microalgae can grow in all of continent from the Arctic to the tropical and can grow faster than fastest growing terrestrial plant, and there can grow in photoautotropic, heterotrophic, mixotrophic, and also contain the most compound that used for the energy sources like protein, carbohydrate, and and lipids. So we can convert lipids to be the biodiesel, we can convert the carbohydrates to be bioethanol, and protein, of course, we can use for the other purposes. So if we see the microalgae sit between plant and animal. So there are many kind of the microalgae. For example, is chlorophyte. There are a lot of feature, a lot of species. So if we pick up one drop of the water, so maybe consists of 10,000 of the microalgae or other organism. So we can imagine if we can use this kind of water sources to be water microbe to be sources of the energy. And Indonesia is an island country, a lot of water, a lot of marine, so maybe suitable for grow aquaculture of the algae and converting to the energy. This is the word mapping. This is word mapping of the microalgae according to temperature factor. So the algae can grow in the 2 degrees Celsius or below the 2 degrees Celsius till to 30 degrees Celsius temperature, room temperature. So in this map, we can see that Indonesia suitable for microalgae cultivation considering the temperature. So I would like to go to the microalgae diversity. So Indonesia have the like biogeography realms line. There are 3 boundary, Wallace line, Weber, and Lydekkers line. Those are about the Indonesian geographic continent development history, which is some belong to the Australian, Asia, and Pacific plates. The condition affecting the floral and fauna distribution. Ministry of the Forest and Environment divided the Indonesian areas belong to be 177 terrestrial ecoregion and 18 marine ecoregion. Each region is very different on topographically. For instance, we can only found orang utan in Sumatra Island to Kalimantan areas. And Manado and Papua, we don't have orang utan. And whether Sulawesi has maleo bird that cannot found in other islands. And we have like cuscus, a small kangaroo in Papua that cannot found in other areas. So this like a virtual line of the Wallace, Weber, Lydekker certainly bring the information about the distribution of the flora or fauna based on their origin in the past time ago. However, from the plantation, we can see look like the coffee or coconut is spread along the Indonesia line. And for fish, we also can see that tuna also we can found in all of our waters bodies in Indonesia. So in this case, the marine food chain is assuming not so different from Sumatra to the New Guinea. So it means the plankton is exists in every Indonesian ocean from Sumatra to the Papua. Okay, let's see the distribution of the green and brown algae. This is the macro algae. We never doing mapping of the microalgae. Indonesia is exporting the macroalgae to every or like Europe America, Japan, and also other country, China. So we are the biggest exporter of the macroalgae. From this macroalgae side, the distribution of green and brown algae are found from Sumatra to Papua Ocean. For example, macroalgae of Caulerpa species can be found from Thousand Island Jakarta to the southeast Sulawesi. The Caulerpa is edible microalgae and sources of carbohydrates in the sea. And secondly, Ulva species can be found in Sumatra and Sulawesi, which has property for medicine purposes. And in addition, the sargassum, another brown algae, also found in all scattered Indonesian sea. Let's see another species of the macroalgae. This is the red algae, also found in all Indonesian ocean, such as Gracilaria species that have functioned as source of the agar compounds. Agar is important material for food, medicine, and energy. Assuming the macroalgae are living in all Indonesian ocean, so is the microalgae. Okay, I will go to the LIPI collection. By series of expedition, LIPI has exploring and collecting the microalgae from several parts of Indonesia. Today, INACC or Indonesian Culture Collection has 170 numbers microalgae from Sumatra, Nusa Tenggara, Borneo, Sulawesi, and Papua. The taxa are a group of heterocontophyte, rhodophyte, cyanophyte, and chlorophyte. Moreover, the microalgal working culture collection in laboratories around 400 samples that collected from Indonesian environments that belong to the diverse taxa, cyanophyte, chrysophyte, chlorophyte, rhodophytes, and others. How we do the collection of microalgae? So we are picking from the natural samples. So we have targeted, for example, the specific environment, high pH, low pH, high temperature like hot spring, and high or dense populations like blooming algae. So we picking from that samples. Therefore, we soaking into the selected media or preserve in the glycerin solution with pretreatment of filtration, dilution, or direct subjection. And therefore, we are isolating the algae. There are three methods of isolating: dilution, or colony pick up by agar plate, or we are directly fishing under the microscope features. And therefore, if we can find one single algae, we put in the well, and we will culturing in the well, and we will monitoring every day. If we are sure there are only single algae, and then we move to the glass and we store it to the culture collection, or we are doing the screening for something useful. For example, this is the properties of the microalgae. So the microalgae can be used for the nutraceuticals product, pharmaceuticals product, cosmeticals product, or therapeutics proteins. And maybe also can use for the remediation agent, also can be used for the health or medicine material. There are like antioxidant, immunomodulator. We can take the pigments from the natural color, etc. And also some reports say that if we consuming the microalgae, certain microalgae can make us the release the stress. So the algae will capture the oxidative compound that inside our body. And in this topic, I would like to focus on the using the microalgae for the energy such as bioalcohol, biodiesel, bio oil, or others. So I would like to introduce the current activities of microalgae research in Indonesia. I pick at some big institutions that work on the microalgae, but I believe there are many institutions working on the microalgae. For example, IPB, Bogor Agriculture University, there are some students and the teacher work for the microalgae for feed, biodiesel, manure, wastewater treatment, and etc. from the small scale to the I think pilot plant scale. And the Gajah Mada University, they have microalgae park, Nokotirto Park, that are like some facility for the public education. And this park also have function for the producing the microalgae biomass. And they use this biomass can be used for everything. And I think the Gajah Mada University also observe the biomass for the biodiesel production. And in South Sulawesi, there are Hasanuddin University also actively work using the microalgae for the feed of the fish. And then we are LIPI Bogor mostly work microalgae for food supplement, pigment, remediation, bioenergy, for example, biodiesel, biohydrogen. Of course, we are doing the culture collection. I think the strong point of LIPI have culture collection of the microalgae. And now, I would like to introduce the activity of research and LIPI concerning to the bioenergy. So we already collect from 9 areas, from the Sumatra, Java to the Lombok Island, or Wakatobi Island, and we using the some microalgae for the lipid production, and we can found that this algae can produce lipid around 30% per dry wet cell, so around 30% of dry wet in wild type. So we try also to engineer this algae to enhance their lipid concentration inside the cell. So we doing like media manipulation, environment manipulation, and also try to do the mutation. Okay, and this is still a result of the research, and in special in particular in this opportunity, I would like to introduce our alkyl hydrogen system combining with the other microbes. So maybe someday we could collaborate with Ihara Sensei laboratory how to produce the hydrogen from the organic material. So we are doing photofermentasi, dark fermentation, anaerobe or aerobe, or combining all those systems to produce the hydrogen from biological material. We using the waste, or we using the simple sugar, or sometimes we also using the complex lignocellulosic. Of course, we have to do the pre-treatment and etc. So as you can see in the slide, so we combining the photofermentation and alkyl system. Mainly, if we are doing the fermentation, we will get two gases. One is hydrogen, and then the second is carbon dioxide. So we, of course, we would not like the carbon dioxide. So we capture the carbon oxide and give the carbon dioxide gas to the microalgae as the source of food of the microalgae. So we hope that the hydrogen produced by this biological product is green hydrogen. So we collecting the agent of conversion of hydrogens from the several area in Indonesia, like we have the Sanur Consortia from Bali. We also have a source from the hot spring, like Rhodobium, Rhodospirillum, the name of the bacteria. And of course, if we are doing only the photofermentation or dark fermentation or single product is not economic of the microalgae system. So we try also doing the refinery whole process of microalgae. Instead of producing the energy, we would like to have another project, such as we have the soil enhancer, we have the pigment that can be used for the natural color, and soil enhancer we use for like a manure. And here we have some already applied in the small garden, and that plants in this picture are cocoa that we gave the microalgae compound look like better growth than others treatment. So we believe we can have some contribution to agriculture part. And what will we do for the next research? So we have some idea if we can culturing many microbes to produce like biodiesel, so maybe better than single culture. So for example, yeast and microalgae, they are combined, so maybe can produce the high lipid and short time, and also maybe efficient is our future works. And yes, I think that Indonesia now try to make the biofuel jet from non-fossil material. So like sugarcane, like another biological material, and one of material also we promoting the algae for producing the biofuel jet. However, we have obstacles here. For example, we have to have the superior strain, and then we have good enzyme to hydrolyze the microalgae cell and etc. So the technology is still our challenge if we are producing the biofuel jet from the microalgae. Although maybe we can produce a large or huge area of the biomass. It's possible in Indonesia. We have our own culture collection. We have like water body that we can use for the aquaculture. However, the technology to convert from the biomass to be biofuel still not mature yet in Indonesia. And I think this will be my last slide. So if we are using the microalgae as fourth generation of biofuel, so we need the technology like efficient aquaculture system, put in freshwater or marine or even a brackish, and we need for the extraction technologies, and we need also post-harvesting technologies that is simple and applicable. We need also spiration technologies, and we also need diversion of demand product, and of course we need also fast-growing and mass culture technologies, and we need some engineering molecular to enhance the strength to produce what kind we need, for example, hydrogen or biodiesel. So I think it's just want to introduce the scenario of Indonesia comparing to the Holland. So in the Holland is already like Ihara said, if Japan already use many energy for the make the power generation. So in Indonesia also try to have solar, wind, hydro, ocean, and biomass and geothermal in the future. So we are trying to increasing the utilization of the new and renewable energy. So we are following the advanced technology to other country, comparing to the other country. And this is our laboratory researchers that mostly ladies. So some only 2 or 3 are men. And we are also have collaboration with NBRC, and also we have visit some the energy company in several places. So thank you. I think this were all my presentation. Thank you for all attention. The times I send back to Haznan Sensei. Thank you, Pak Haznan.
Thank you very much, Professor Dwi, for your nice presentation. I don't want to summarize your presentation. Maybe in the next, after this, after the last presentation, we will have a discussion. So the next presenter is Associate Professor Suntoyo. Before you present your presentation, I will read your biography. So Suntoyo was born in Sepuluh, Central Java, Indonesia, in 1971, and he got the associate professor in the Ocean Engineering Department at Institute Technology Sepuluh November ITS Indonesia since 2011, and he awarded BIOENERGI in 1995. So, and master degree in civil or coastal ocean engineering in 2003, and his Ph.D. in engineering or in civil coastal ocean engineering in 2006. So in the Tohoku University, Japan. And he awarded the postdoctoral fellowship by Japan Society for Promotion of Sciences, JSPS, from 2006 until 2008, and he published more than 120 papers in scientific journals and referred conference proceedings. So his major interest in research is wave boundary layer and turbulence modeling, development of spectral wave models, ocean wave propagation modeling, and renewable ocean wave energy generation, coastal protection and ecosystem, climate change and sea level rise impact for coastal management, coastal modeling, and morphological change. So he has many professional experience from the 2004 until now. And now he is the head of the postgraduate study program for marine science and Institute of Marine Technology, IPS, and he has also the professional society involvement, and so many invited talk and guest lecture. So it was the biography of Professor Suntoyo. So now is the time is yours from Professor Suntoyo to present your presentation. Thank you. Please.
Okay, thank you, Dr. Haznan Abimanyu, as moderator, for the time given to me. And at first, thank you very much, Professor Dr. Wahyu Dwianto, for organizing the JSPS Alumni of Indonesia lecture today. And today, I would like to talk about the my talk entitled The Potential of Ocean Renewable Energy in Indonesia. And before that, maybe Dr. Haznan already introduced for me. I'm a Suntoyo from Department of Ocean Engineering, ITS Surabaya. And this is the presentation overview. This is a sequence of my presentation. At first, I would like to introduce about the Indonesia energy situation, as followed by the ocean energy as renewable energy solution, with energy overview and technologies, with energy converter, the importance of the ocean wave measurement data in Indonesian water, and barrier to ocean energy technology, and current status of the feasibility study of ocean energy technology in Indonesia. And finally, the drivers of the barrier related with the potential ocean renewable energy in Indonesia. And let's see, this is the current state of the Indonesia energy situation. So that since 2008, Indonesia is no longer as a oil exporting country. This is caused by change in Indonesia energy story from OPEC members to oil importers. The prime era of the Indonesia oil since the 1980, which began to decline since the 2000 years. Recently, the government has taken active steps to reduce subsidies and oil product as a country increases dependence on import of the petroleum product amid a decline in domestic oil production and an increased request. And the import era, we can see here that to look up along with the decline in the oil production since 2003 here. And the inability to reach the required electricity demand and gas or oil price escalation can be understood as a critical energy security risk over here. And in order to respond to both environmental and security risks, the renewable energy is considered as the best alternative solution for the future. Therefore, renewable energy contribution should be increased to maintain sustainable development. Renewable energy is regarded as an unlimited supply of the natural resources with a much lower impact on the environment, for instance, solar energy, wind power, ocean energy, etc. To supply all of the energy demand in the world, further research and development are needed in the renewable energy sector. This is given by the Minister of the Energy and Mineral Resources. And this is, let's see, to explain about the on-grid power generation capacity in Indonesia for the year 2014. We can see here that the on-grid power generation capacity stood at the 63.1 gigawatt at the end of the 2014. Since 2010, nearly about the 20 gigawatt of generation capacity has been added to the grid. Most of which 13 gigawatt was new coal power capacity. Geographically, more than 70% on the grid power generation capacity is on the Java, Bali, with a total of the 37.5 gigawatt on grid generation capacity from there. And the share of the coal-fired power capacity at about the 55% on Java, Bali is higher than in other regions. And renewable power has higher share in Sulawesi and Nusa Tenggara is about 39%, and in Sumatra is about 17%, due to mainly to utilization only for the hydropower resources, not other renewable energy applied in this area. And oil-fired power generation plays a larger role in the island of the Kalimantan and in Maluku and Papua also, where the use of smaller scale diesel generator is still widespread. So we can see here that related with the renewable energy potential and implementation, this data come from the Director of Various New and Renewable Energy 2019, belong the Minister of Energy and Mineral Resources. And we can see here that for example, the ocean energy have potential is about 70.9 gigawatt, but up to now still didn't implement it yet. And other one is the geothermal. The resource is about 11 gigawatt, reserve is about the 70.5 gigawatt, and already installed is about 1.9 gigawatt. It's about 44%. And the other one is bioenergy. Its potential is about 22.6 gigawatt, and this is a biodiesel is about 200,000 YPS, and installed is about 0.42%, and other one is installed about the 0.04% related with the wind energy, and actually the resources is about 60.6 gigawatt. Another one is the hydropower energy. The resources is about 75 gigawatt, and installed is about 0.02% gigawatt. And we can see here that the total potential renewable energy in Indonesia is about 442 gigawatt, and installed is about only 9.32 gigawatt, is about 2%. And due to that, ocean energy as the renewable energy solution, I think. And one of the promising and resources abundant renewable energy option is ocean energy. A recent study shows that the annual theoretical potential of ocean energy is estimated to be between 4 and 18 million tons of oil equivalent per year. This is by Deduction et al. 2007, and it also has the potential for global deployment of around 337 gigawatt, and can generate more than 885 terawatts of electricity annually. This is given by Adres et al. 2017. And another study also stated that global ocean energy reached up to 32 terawatts, according to the Wahyudi et al. 2017. And this large amount is generated from various forms of the ocean energy. Ocean energy, according to Ocean energy, according to the Esteban and Larry 2012, consists of the 6 types, namely tidal rains, tidal current, ocean wave, ocean current, ocean thermal energy, and salinity gradient. And thus, ocean energy has a significant role for the future energy system. This will contribute to the reduction of the carbon emission and also increase economic growth in coastal and especially remote areas. This has attracted a great deal of interest to improve technology and energy maturity given by the IRENA, the International Renewable Energy Agency, 2014. And here we can see that the Indonesia and its ocean energy potential. We know that the Indonesia, an archipelago country in tropical Southeast Asia, is considered as one of the countries with the most ocean energy potential. Indonesia has an area of 2/3 covered by ocean, and the length of the coastline is about the 54,716 kilometers. Theoretically, Indonesia has a total ocean energy potential, a combination of the ocean thermal, wave, and tidal current is about 4,676 gigawatt, and practical potential of around 216 gigawatt. This is a claim by HDM 2017. And even though with this statistic, Indonesia could light up the world with electricity produced by the ocean, Indonesia has still not been able to maximize its ocean potential. According to the IRENA 2017, Indonesia is among the world's fastest growing nation in energy consumption. And based on this fact, Indonesia, through the Minister of the Energy and Mineral Resources, under the Director of the Renewable Energy, made a roadmap about the future energy, including their plan to utilize the ocean energy, especially in wave, tidal current, and also ocean thermal. However, this is we can see some ocean thermal energy conversion. We can see here that the energy source OTEC utilize the temperature gradient of the ocean in heat exchanger of the Rankine turbine, and large test facility in Hawaii produce 105 kilowatt after $5 million upfront. But however, Japan, Australia, and other countries produce more than 10 megawatts. And this is one of them, ocean energy. And another one is ocean current energy. Energy source, continuous flow of the ocean due to the surface wind, water salinity, temperature, ocean floor topography or bathymetric, and the earth rotation. Similar turbine technology to tidal, but far less mature, much more difficult to construct due to the very deep water depth, and much more power cables would be needed and harder to determine ecological ramifications. And this is another one, is tidal energy. Energy source is come from gravitational pull of the moon from tides. We can see that in this animation, this tidal barat, this velocity of tidal flow here and can move the turbine here. And also we can put the tidal barrage in near the estuary. This is a sea and this estuary. We can construct here and put the turbine and generator here. And turbine capture energy from different water level, and dam is full of the turbine. Energy collected in the both direction, in the sea direction and also in the estuary direction. And another one is we can see here that the freestanding wind turbine anchored to the seafloor. This depend on water depth and lower upfront costs and less constructed energy. This figure animation we take from the Aquarium 2008. And ocean wave energy overview and technologies. Here we can see that the energy source, wind blowing on the ocean surface, we can see here that in longitudinal wind path, especially waterless, are most promising location. This is took off after oil crisis in 1973. This is the wave propagation due to the wind flow and wind direction. And wave energy technologies, so in the arena 2014, based on the Paris and Iglesias 2012, and there consists the oscillating water column, turbine, air turbine as the and the potential take of the energy system, and there are fixed structure and also floating structure, depend on the condition and purpose. For example, the fixed structure isolated, for example, already installed like Pico, Limpet, and another one is Breakwater. Namely, the already installed also Sakata, Mutriku, and nearshore condition fixed for a fixed structure up to now at a conceptual level, and still there is a good construction to construct near the shore. Another one is floating. This mighty wall and also ocean energy, Superboy and Ocean Link. And another one is oscillating bodies. This is consists of the hydraulic motor, hydraulic turbine, or the electrical generator as the power take-off system. They are fixed structure at the shoreline, is called by echo wave power. Another one is floating, essentially transition heavy, aqua buoy, IPS buoy, and another one, and so on. And another one is essentially rotating. That is Pyramis, PS frog, sea reef, and essentially translation heave. This is RWS and also rotation. This is with frog and oyster. And also we can use the overtopping phenomena. This is use the low heat hydraulic turbine as the potential takeoff energy system. They are fixed structure and also the floating structure. And perfect structure already installed is Tapchan, but there is no developed for another purpose. And this shoreline without the concentration SSG, and for floating structure with concentration with dragon and with cat. And to convert the energy from wave to become the electricity energy, we use the wave energy converter. Different wave energy converter absorb, sway, and heave. Component of the wave energy technology is consists of the structure and primer mover to capture the energy of the wave, and foundation and mooring system should be installed there to keep the structure stable. And power take-off system that convert mechanical to electrical energy and control system for safety and optimization. And this is for the wave energy converter technologies is we can show about the attenuator, point absorber, oscillating wave short converter, oscillating water column, OWC, overtopping device, and submerged pressure differential. And it is a kind of the attenuators, long multi-segment structure float parallel to the wave direction. We can see that due to the wave direction, the attenuator moves related with the wave movement. And right the wave device motion follow wave motion. Relative the motion of ponton convert energy to the hydraulic circuit or mechanical gear train. And another one we can see here, we can put along the course here. And for the terminator overtopping device, we can see in that this is a overtopping system. We can construct the construction like this, the wave overtopping here and fill in this reservoir and can move the turbine outlet. This is a turbine installed here and connected with the energy converter, we can produce the electricity. And capture water wave and enter into the storage reservoir here, and the water pass through a top heat turbine and return to ocean through the outlet here. And shoreline or floating moored structure also can be installed like this. Another one is point absorber. We can see in that a floating buoy that rises and falls with its passing wave. This depends on the wave direction and also wave height and wave period also. And movement is used to pump hydraulic fluid in a column below the surface, which is used to rotate the generator. First, water electrical to achieve the large scale development. And the important thing of the ocean wave measurement data in Indonesian water, up to now, we are very difficult to find the ocean wave data in Indonesia. And the ocean wave measurement is very important. This is for in-situ wave observation can be used to access the quality of the ECMWF or European Center for Medium Range Weather Forecasting with computation model and its rule for the Indonesian ocean water. The development of the spectral wave model for Indonesian water also very important because up to now still there is no standard formula for the spectral Indonesia, especially Indonesian ocean water. And the accurate of robust of the ocean wave model can be used for the prediction of the renewable wave ocean wave energy and the calculation of the wave load, its interaction on the marine structure, include the renewable energy structure here. And we already collaborate with the Center of Navy Hydrography and Oceanography or Pusat Hidrografi and Oceanography Angkatan Laut here. We have the doctoral student before and already graduate in this year. And they installed the wave recorder was installed at the offshore platform structure here. This is already measure wave around here by put the wave recorder installed in the offshore structure, the platform of Cinta, in the name of platform here. And another progress is maybe will be measured around here. This is a southern hemisphere and open sea. Deep water is more than 800 meters. The kind of the wave is swell here, and another one is in the northern hemisphere. This deep water is more than 400 meters. This is close sea, and another one is this one is northern hemisphere in deep water and more than 400 open sea. And based on this measurement data, we can use to make a validation, also develop the spectral formula, and also based on the Indonesian ocean wave data. And after that, we can use for another purpose. And this is the location of the offshore platform Cinta here. We can use the lowest live uninterrupted water sensor as a wave recorder. We put and install here. And this is the instrument installation on the 30 May until 1st June 2015 with the right safety procedure at the Pabelokan Island and at offshore platform Cinta. And before that, there is a safety induction here, and some people will install and put the wave recorder, and in the same situation. Also, they measure the tidal and also wind direction and wind magnitude. And this is a figure. We can see some photos related with the activities. And this is Bioluvas can make measurement with a measurement frequency of the 6 hertz. In other words, the tool is able to record in 1 second 6 data is obtained, and this wave measurement was carried out for the 1 year. And this is analysis data, and like this, it takes some result for measurement. And for more detail about the measurement in the Western Java Sea and its preliminary characteristic analysis for the wave already published in this journal. And another one is related with the improvement of the ultrasonic sensor-based device for direct ocean measurement program at Western Java Sea, already published in this seminar. For more information, you can read the paper, I think. And another problem is about to implement the ocean wave energy. There is a barrier to ocean energy technology, and there are technology challenges, economic and market, environmental and social issue, and also infrastructure facilities. This is given by key harder to overcome by Adi Kusuma 2018, adopted from INACC 2014. And the technology challenges like this. First is basic concept principle and update to the technology concept formulated, and after that experiment of the concept and validation with lab experiment, and also we can make the simulation with numerical model and the realistic working experiment in lab and engineering pilot scale, and after that full scale prototype demos in actual environment, actual system completed and ready for the deployment, and technology ready for expected lifetime. And for all the technology with ocean with technology, I think, like the salinity gradient, deep ocean current, OTEC, and also full scale being tested for VAC and also tidal current and also tidal range technology. And this is also given by Adi Kusuma 2018, updated from INACC 2014. And based on this, some result also current status of the feasibility study of ocean energy also given here. This is based on the SDM data for the ocean energy potential in several provinces. For example, West Nusa Tenggara, Rio Island, West Java and Lampung, West Papua, East Nusa Tenggara, and also Bali. The totally is about 287,822 megawatt for theoretically, technically, and on only about the 71,000, and practically it's about 17,000. And this is another tidal current resources data in 13 states of Indonesia. This is based on the SDM 2017. In Rio, Sunda, Toya, Pakai, Nusa Penida, Lombok, Alas, Molo, Larantuka, Boling, Pantar, Mensuar, Lirung Talaut, Sugirio, Lampa Natuna. And another one is some researchers in Indonesia from ITB and other university also carry out some analysis and feasibility study related with the ocean energy technology in Indonesia. This, for example, Triasdian et al. 2018 related to the energy capture potential of existing with energy converter for Indonesia Sea. The simulation result was also used to evaluate selected with energy converter and to determine their energy capturing capability in potential site of the Indonesia water. The result is reflected. Selected site indicated what the with energy resources in the Indonesia Sea reach is about 74.65 kilowatt per meter. This is some selected area near the Lampung Island. This is, for example, it's about 157 megawatt by mean of rotating variant, and other devices, for example, heaving devices is about 14.3 megawatt and other devices here. And we can also show some other result related with the Amrisal et al. Related to the preliminary study of with energy resources assessment and its seasonal variation along the southern coast of Java. This is some result here. And another one is by Orhan et al. Orhan et al. In 2017 related with the investigation of the energy potential from tidal stream current in Indonesia. This is already published in the coastal engineering proceeding. And in this paper, an advanced methodology developed for the assessment of the tidal stream resources is applied to several straits between the Indonesian Ocean and inner Indonesian seas. And due to the high current velocities up to the 3 or 4 meters per second, the straits are particularly promising for the efficient generation of the electrical power.
Excuse me, Professor.
Yes.
Could you please speed your presentation, please?
Yeah. And another one is related to result ending say, republished an ocean with energy potential here. And current status of the ocean energy is still state of the development from the conceptual up to the demonstration still tidal as a little further. And this is for the SI ocean energy cost projection. We can see based on the IRENA 2017. And this is the first barrier related with the first is environmental impact. Based on the preliminary study, our project with energy seem to have a low environmental impact or disturbance, including many landscape implication. The mindset effect is reduction of the wave climate, consequently on the wave height, and the up of the cost. However, there's a number of areas similar to the other ocean energy technology, where energy technologies environmental impact. Another one, and the need for the investment is very important, and insufficient infrastructure, and also planning and licensing procedure. This is due to the fact of the fact that wave energy as well as the other marine energies are dependent upon the specific geographical setting, and predefined zoning plan will help the sector to adopt a much better way to overcome the local independent. And this is the end of my presentation. Thank you very much for your attention. Thank you, Pak Haznan.
Yeah, thank you, Professor Sunyoto, for your nice presentation. We are sorry to delay this lecture. So I think this is a good chance for us to have a discussion for what the presentation, what the presenters has already presented their presentation. So I will give time for Professor Ihara to have comments to the two other presenters.
Okay.
Please, Professor Ihara.
Okay, thank you for your question. And the first question, let me see that. And the first question is, do you see a tropical country joining your project? Yes, the answer is yes, partly yes. I will share my presentation slide again. Yes, this is participating the institution. And Thailand, the National Science and Technology Development Agency, participated in our consortium. So the Thailand is kind of the tropical country, I think. And so, yeah, that is first question. And the second question is that, yes, very interesting question. Do you have some suggestion how to increase solar energy utilization in Indonesia? Okay. Yes, the question is, I checked during and after this question, I searching using the internet, and I searching the hours of sunlight in each country. In Japan, is average about 2,000 hours per year. And the average of the world is about 2,500 hours. So the Japan's hours of sunlight is not so good for the solar cell technology. And Indonesia, I'm sure, just searching, and 3,300 hours a year. I'm not sure it's exact weather condition in Indonesia. I think sometimes you got hard rain, I think, and cloudy day and this, but I think using this data and the hour of sunlight is wrong. And Indonesia also the 2,600. So using this simple setting, I'm just a pre-checked for each person I will ask you. And but if this data is correct, and yes, the solar cells, solar energies, the utilization, the possibility is high, I think. And but the common technological issue exists to improve the renewable energy. It's this common technical issue. The first one is that this one. Yep. Can you see that? This the generation cost of the hydrogen.
Hydrogen, yeah.
And the hydrogen is a very important, important media as storage. So, but this cost is not enough. And also, I always propose that everybody is that a system, the energy resource aggregation, the concept. It means that this solar panel and wind power sometimes, and also the fuel cell, is the capacity always is not so big. So, but sometimes we have to collaborate with operating with the larger electricity grid. So that the concept of the resource aggregation is necessary using the internet. Independent power sources is a very small size, but integrated by using the internet technologies, so that operatively, and increase the total amount of electricity is increased. And so that we can operate it totally and using internet technology like a large scale power plant. So this technology is necessary to increase the total renewable energy power sources. So furthermore, I think that I'm not sure it's a lot of investigation is necessary. Is one possibility in Indonesia is using the sunlight, solar source, and making the hydrogen. And hydrogen can maybe Indonesia's country can try or export, like Japan. There's many countries. One possibility for the business. So I think the technology is in always connecting to the business and also the human society itself, reducing the carbon dioxide emission. So it means that we have to improve the renewable energy, and to improve the renewable energy, we have to reduce the production cost of the hydrogen. One of the case for that. And to reduce the hydrogen cost, of course, and if I focus on just only the solar power, okay? So it's ROG is one possibility, of course. And yes, wave energy is one possibility. And I said focus on the solar cells energy, and we control totally, and using the internet, using big and using the data and total system as we construct it and improve the renewable energy for like solar cell and wind power, and with mixture of the solar and any energy, renewable energy sources. The point is that renewable energy is depend on the country. It depends on the region. So that we have to think about original scheme to improve the renewable energy. So one possibility is that making hydrogen export to any countries like Japan. So one possibility for the improvement of the solar power in Indonesia. That's all. Any other question? Yes,
Okay, thank you, Professor.
I can answer it. Is that all?
Yeah, thank you, Professor.
Thank you, Prof.
Thank you. Thank you for your question.
Okay, next is, do you have comments to the other two presenters, Professor Ihara? Do you have comments to other two presenters, Professor Dwi and Professor Sugiarto?
Yes, interesting. Thank you for your presentation. And so, as I said, my comment part, so renewable energy, especially renewable energy, is very, very dependent on the country and the region. So we have to think about the weather condition and also environment and site situation. We have to think about it. So, but I can say that when you increase the ratio of the renewable power, renewable energy sources, so we don't so concentrated one technologies.
Okay.
The combination is necessary. there is no way to the magical power generation in the world. So we have to mixture as efficiently and smartly, and using some yes, wind analogy and wave, and every energy is possible to improve, and the collaboration between the energy sector, every sector, various sector, to improve the and renewable energy, and then we can contribute to the sustainable society in the future. So that's a comment. Thank you very much for two professors. That's my comment.
Okay, thank you for second. So, Professor Dwi, do you have any comments for Professor Ihara or Professor Suntoyo?
Yes, thank you, Haznan Sang. I would like to not ask, but it may be asked to Prof. Ihara. I'm really interested in your hydrogen storage technology. So now I can make the hydrogen from the biological sources or maybe other sources, but now in site I make the hydrogen. I just release the hydrogen to the air, so I need the technology of hydrogen storage. So maybe I propose to have a like collaboration work through this media for the hydrogen storage technology. Yeah, would you like to collaborate with me, Prof?
Sure.
Yeah. Yeah, because our lack technology, our obstacle, we can have hydrogen, but we don't have or small information about the hydrogen storage technology. Therefore, if we have this kind of technology, we can exporting the hydrogen to Japan.
Yes.
Yeah. So maybe
there's some technology for the energy carrier.
Yeah.
So we have to think about the supply chain, and each technology we have to develop each other and collaborate, and think about how much scenario, how is the scenario power the future energy system. So that is the point. Global collaboration is very always welcome and always have to proceed. It's very important point in this future energy system.
Yeah. Arigatou gozaimasu. So Pak Wahyu and Otani Sensei, please help me. So for Suntoyo-san, I think I agree with Prof. Ihara Sensei. So we should aggregate on combine all energy to be power generation in then one area. Once time, me and Pak Wahyu have been visit one island that already use renewable energy. So they are not use the fossil fuel. They use the wind, ocean, biomass together. So I agree we should think about the aggregate material to produce the energy. So also I am very happy that Prof. Suntoyo already have developing the ocean energy in Indonesia. Thank you for the presentation.
Thank you, Professor Dwi. And Professor Suntoyo, do you have any comments for the Professor Ihara or Professor Dwi?
Yeah, thank you very much, Pak Haznan, and also Bu Dwi, Susilaningsih. And I have a simple question to Professor Ihara, especially. Could you consider about the ocean wave energy involved in your consortium, smart energy consortium?
Yeah, no, as unfortunately now the wave power generation using wave power, under present time under this consortium, there is no researchers on the wave, but yes, but possible in the future.
Okay, thank you very much.
There is no company research on the wave power, and actually, but yes, it depends on the country I said. So yeah, that is my answer.
Okay, thank you very much.
Okay, one more not the question actually. This is the statement from Professor Otani that the integration of various energy generators in wider region is the issue today. So how about this statement? Do you have any comments, Professor Ihara, Professor Dwi, or Professor Suntoyo?
Yeah, Pak Haznan, actually in Indonesia have scenario to mix all the energies sources as the power generation. However, I think not so beautiful as the Prof Ihara have system. I believe we could learn from Japan or from other association how to aggregate on how to integrate all the energy sources to be power generation. So we need to learn to other advanced country to have this kind of system. So maybe we can have some collaboration or we can have some project in this energy in the JSPS alumni or JAAI alumni. Maybe we can propose to Pak Wahyu and Otani Sensei.
Yes,
Okay.
one possible
Yes.
thing is using the PhD student and
Yes,
JSPS scheme has an educational program.
of course.
Yes, this is I said this point as Tokyo Tech strategy, education and research work is both function is very important to change the energy system, to change the energy society. So the globally would like to require and recruit this excellent student. If every professor knows a very excellent student, please recommend apply to the special program, RISE program.
Okay.
And it's very good condition for the student. So using the education program,
Education program. Okay.
collaboration. I think one possible collaboration between us.
Okay. Okay, Sensei.
Okay, thank you very much for the presenters. Maybe I will conclude today lecture because we are over time now. So as a conclusions, maybe there are 3 points. So we have, first is we have many energy resources to be utilized, especially in the tropical countries such as Indonesia. The second one is we need the integration or a grid or a smart grid of the variation energy resources for the wider area. Maybe we have the common grid for every countries. Yeah. So, and the third one is we need the intensive collaboration in the future for undergo the problems and barriers of this utilization of the energy resources. So there are my conclusions for today's lecture, JAAI lecturer. So from before we closing this question, so is there Miss Sachiko Hashimoto still here in the room? Yeah, I think I saw this. The name Sachiko Hashimoto. Could you please have some comments about this lecturer, JAAI lecturer? Ms. Sachiko Hashimoto is International Policy Planning Division of the Headquarters for International Affairs, JSPS. So, Ms. Sachiko, could you please deliver comments for this lecturer?
Hashimoto-san はいらっしゃいますか? Yes, I calling in Japanese.
Oh, okay.
橋本さん、JSPS の橋本さんはいらっしゃいますか?
もしもし、はい。
はい。
コメントを求められてますけど。
Sorry, I'm working from my home, so I can't use my camera.
Okay.
If it is okay, I just make a comment. Because I usually work for the Kobe University in Japan, and as a student affairs section, we receive a lot of PhD students from LIPI. So from this seminar, I learned a lot about how to study in the Indonesia. So I hope in the future, the university in Japan and the university institution in Indonesia will make a collaboration using this kind of opportunity. Thank you.
Okay, thank you, Ms. Sachiko Hashimoto, for your comments. And we are now in the final closing remarks from Professor Yoshio Otani, the director of JSPS Bangkok office. And please.
Yes. Thank you very much for the great arrangement of second JAI seminar, Dr. Haznan and also Dr. Wafyu. The work of Ihara sensei is very fascinating. I think many researchers in Indonesia have a lot of interest in your research. So I hope, as mentioned during the discussion, please accept potential researchers from Indonesia. I just commented in the group chat, integration of various energy sources important. But how widely we integrate the energy sources? I think hydrogen is one of the means to broaden the integration area. So utilizing hydrogen, maybe we can connect energy sources in Indonesia and also in Japan, I hope. We had a Zoom meeting of directors of JSPS office the other day, and we have 10 overseas offices, JSPS offices around the world. And I think half of the directors of JSPS office are still in Japan. They cannot go back to offices because of COVID-19 pandemic. And we talked about what we should do during this period for the COVID-19, what Alumni Association should do during this difficult period. And we all agreed this kind of a web meeting is very useful and effective for academic seminars which discuss specific topics. But for the activities of alumni associations, I think the most important thing is we have to face to each other so that we can exchange various informations and we can deepen the friendship, something like this. So please consider to have a face-to-face meeting in a small group and inviting others by online internet. And I think of course you have to think about COVID-19 situations in Indonesia, but I hope third symposium will be in face-to-face meeting, and I hope to join the third meeting of JAI. Thank you for joining today. Thank you. This is all.
Thank you. Thank you, Professor Otani, for your closing remarks. And for the attendees, please show up your face. Please turn on your video. We are going to have the photo session. So the organizing committee will take the photo of us. Please on your video.
Okay, I will take a picture.
Okay.
I count from 1, 2, 3. 1, 2, 1, 2, 3. Okay. For another page. Second page, please open your camera, please. Nobody. It's okay. Okay, I already took a picture.
Okay. Okay, thank you very much for the presenters, the Professor Otani, JSPS Director in Bangkok, and Professor Wahyu Dwianto as the Chairman of JAAI, and also the attendee of this lecture. So I'm sorry for for me as a moderator today, if there are some errors and some mistakes from me. And thank you very much for your attention. And I close with the good afternoon and good night. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Thank you
wabarakatuh.
very much.
Thank you very much.
Bye-bye.
Everybody.
Bye-bye.
お疲れ様です。
お疲れ様でした。
Yes.
失礼します。
Any question?
Arigatou
Unfortunately,
gozaimasu.
it will accommodate. I'm sorry about the question which cannot be answered this time. Thank you very much.
Thank you.
See you next time.
See you next time. 失礼します。
Sama Desta.
お疲れ様でした。
Makasih Bu Dwi. Pak Jarwanto, matur nuwun.
Assalamualaikum Prof. Wahyu dan teman-teman. Mohon izin.
Ya, terima kasih Pak.
Oke.